I have a proportion question for you, and this does not require any calculation whatsoever. So, the time taken for a planet to revolve around the sun is called the period of the planet. This is just some information for you. The following table shows the mean distance d kilometers and the period p years of the 8 following planets. So for example, Mercury has a mean distance of 57.91 times 10 to the 6 kilometers and a period of 0.241 years. You can just see the rest of this table on your own. And the question, an astronomer found that d to the m and p to the n, where m and n are certain positive integers, have a certain proportional relationship, and we're asked to find what is this relationship. Now I want you guys to observe the values of d and p in the following table. Notice that the values for both d and p both increase. So as you can see, d increases downwards and also p increases as well. Recalling that if two variables are in direct proportion, then if one increases, then the other must also increase as well. We have the following property. So we have when d increases, we have p also increases. So this most likely implies that d to the m and p to the n are in direct proportion. Now you might say, well, you can just assume that they are directly proportional immediately because we have d to the m and p to the n. We don't really know what m and n are. Well, no matter what values for m and n that you choose, these following numbers will always follow an increasing sequence. So for example, if I take both m and n to be 2, then if I square all of these numbers, they will all follow an increasing sequence. So that's why we can assume that they are directly proportional. Now you may be wondering what is all about the astronomer stuff and about d to the m and p to the n. Well, this is strongly related to a thing called Kappas Third Law of planetary motion, published by Johannes Kepler between 1609 and 1619. So it says that if we have r as the distance from a planet to the sun and t as the orbital period of that same planet, we have that t squared is directly proportional to r cubed. And notice that 2 and 3 are our values for m and n respectively in the question. And although I've said that r is the distance from the planet to the sun, in some sources you might find that r is actually the length of the semi-major axis of the orbit of the planet. And if you don't know yet, planets orbit around the sun in the shape of an ellipse, not a circle. So that's a little bit about physics, which ends this video.